In this tutorial, we are going to cover the smooth moving average example of time series. So first we are importing our libraries NumPy and Pandas as usual, then matplotlib and seaborn. So smooth moving average, taking an example, I'm reading data from an exchange rate file. It has basically two columns, one is month and other is the exchange rate value. Then setting the index of particular data set as month, which is the first column that was there in the file, and then I'm just splitting the data into the train and the test data set. So let me just quickly do this. So okay, I have to load the libraries first. Okay, this is what the data looks like. So data is stored in the data frame, and the index is set as month. So this is the number of months, okay, and then the column is exchange rate TWI. Okay, okay, fine. Now we have split the data into train and the test. So the train data contains from 0 to index 211 and 212 onwards belongs to the test data set. And I'm also storing the length of the train data set in a variable length underscore train. So now what I've done, I'm just created a function called as SMA. So what I'll do, I'll pass to it three values. First is the data frame itself. Second is the window, like what is the window I want to use for calculating the smooth moving average. And the third is the length of the train. That is how many records are there in the train data set. So first, I'm just making a copy of data frame that is passed and storing it in another y-hat SMA. So that will become another data frame, which is basically having a copy of DF. And then within this, I'm creating a new column SMA forecast, and it will have a value uh, which is based on the first column which is present in the data frame DF, whose copy we are taking it in y-hat SMA. And so basically it's a rolling window. The window is what is passed to this function, and we are creating the rolling mean average. And since we know that uh, we know the length of the train data set, so basically what we have to do, all the records which come after the train data set, that is the records which belong to the test data set, those records should have a forecast value which is the last forecasted value of the train data set, because this is what smooth moving average does. Okay, so this is what I am setting it up in this particular line, and then I'm calculating the average. So average is again basically the difference between the actual and the forecast value, and then calculating the root mean square error and the MAP. I'm just printing these two values and again doing a plotting of train, test, and the forecast values. So this is a generic function that I've created, and what I'll do, I'll call this function and will pass values for these parameters, and will plot different things. So first I'm calling SMA with the data is our actual data, and the window is 12 months, and the length of the train data set that we are passing. The only thing that we will change in our different calls is the length, is this window period. So we can compare smooth moving average with the different window period like 12 months, 6 months, 3 months, and see which window suits best and is giving less errors. Yeah. So for the 12-month smooth moving average, this is what our graph looks like. So this is the train data set that we see, the blue color. Green one is our forecast, and this orange one is the test data set. So this is the 12-month smooth moving average. It is having a root mean square error as 4.6 and maybe 6.95. Now if I change it to 6 months window, again calling the same function SMA with the data 6 and length train, so 6 is the window period. If you see, this is how the graph now looks like, and its RMSE is 4.9. Earlier it was 4.6, and MAP has increased to 7.12. Earlier it was 6.95. So the error part has increased if we have shortened this window period from 12 to 6 months. Again, just doing it again for the 3 months period. Again, RMSE is now 5.98. Earlier it was within 5, and MAPE has increased beyond 8. So it means as we are shortening our window, what we are observing that the error term is increasing. What it means that we are allowing more noise to filter into our model, and that is because of which we are having higher error values when we are shortening the windows. One thing you would notice that for a shortening window, because it is a very short window, so the forecast value will more or less follow the actual trend. And for the 6 months window, there is a lesser lag between the peaks and the troughs. And if you see for a 12 month window, there will be a more lag compared to the 6 month. But the thing is, what we observed that the error part is least for this 12 month window. So this is the model for the smooth moving average. This window, 12 window, is better compared to 6 and the 3 months window. Okay, we'll take different more examples in the coming lectures. Thank you for now.